Hi, this is Algebra 2, Lesson 92. We're going to talk about boat in the water problems. We're starting on page 382. Robert has a boat that has a rate of 11 miles per hour in still water. If the boat, with the motor turned off, is placed in a river in which the water flows at 3 miles an hour, the boat will drift downstream with the current at 3 miles an hour. If Robert turns his motor on and goes downstream with the current, the boat will travel at 11 miles per hour plus the 3 miles per hour of the stream. Okay? So the boat travels at 11 miles per hour. The stream, the water, the current of water flows at 3 miles an hour. So if the boat engine is on and it travels with the water, it's going to go at 11 plus 3, or 14 miles per hour. If Robert turns his boat around and goes upstream against the current is going to be pushing against his boat at 3 miles an hour. So the boat's rate is going to be 11 minus 3, or 8 miles per hour. In general, the downstream rate equals the rate of the boat plus the rate of the water, which equals the rate downstream. That means with the current. Your upstream rate, or the rate against the current, is going to be the rate of the boat minus the rate of the water, because the water is pushing against the boat. And that's going to equal the rate downstream. Okay, rate times time still equals distance, so the rate downstream times the time downstream equals the distance downstream. And the rate upstream times the time upstream equals the distance upstream. So you can substitute the boat plus the water and the boat minus the water for the rates, and you get these formulas for distance downstream and distance upstream. The quantity boat plus water times time downstream equals the distance downstream, and the quantity boat minus water times time upstream equals the distance upstream. We can use these to solve lots of boat in the water problems. So let's try some. Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what was their times? So, the distance downstream is boat plus water times time downstream. Their distance upstream is boat minus water times time upstream. Okay, so their distance, they're going 60 miles downstream. So 60 equals the speed of their boat is 8. So 8 plus, we don't know the rate of the current yet, times the time downstream. Okay. The distance upstream is 20 miles minus the rate of the boat is 8. We still don't know water, and we're looking for the time. The time downstream in this problem equals the time upstream. So we're talking about the same time. So in both of these, we can just use t and drop the subscripts because the times equal each other. So we have 60 equals 8 plus w times t, and 20 equals 8 minus w times t. So if we work this out, we get 60 equals 8t plus wt, and 20 equals 8t minus wt. Okay, we can use elimination and solve for t. So 60 minus 8t equals 8t plus wt, and 20 equals 8t minus wt. Those cancel. We end up with 80 equals 8t, divide by 8, and time equals 10 hours. Why isn't that right? Oh, because this is 16. Sorry, 8 plus 8 is 16. So we're dividing by 16, and this is 5 hours. Okay, so time equals 5 hours. Now we're going to solve for the W in both equations. So 60 equals 8 plus W times 5. 60 equals 40 plus 5W minus 40 minus 40. 20 equals 5W divided by 5. And the speed of the water is 4 miles per hour. Okay? Let's check that by also substituting into this one. See how we have 20 equals 8 minus W times 5. 20 equals 40 minus 5W. Subtract 40 from both sides. And we have negative 20 equals negative 5W. Negative 5W equals negative 20. Divide both sides by negative 5. And W equals 4 miles per hour. So the time upstream and the time downstream is 5 hours, and the water current was moving at 4 miles an hour. Okay, let's try another one. The steamboat Juby Fountain could go 70 miles downstream in 5 hours, but required 6 hours to go 48 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? So, the distance downstream equals the time downstream times the boat plus the water. The distance upstream equals the time upstream times the boat minus the water. So downstream, we're going 70 miles in 5 hours. Boat plus current. And upstream, we're going 48 miles in 6 hours. Boat minus current. Okay, so we have these two equations, and we're going to solve for boat and current. Before we multiply these through, if we divide this side by 5, and this side by 5, and this side by 6, and this side by 6, we'll end up with 14 equals boat plus water, and 8 equals boat minus water, and that saves a couple of steps of simplifying. Now we can put these together and do elimination and solve for the speed of the boat. So we have 14 equals boat plus water, and we have 8 equals boat minus water. So if we add these together, the waters are going to cancel. We have 22 equals 2 times the boat. So the boat equals 11 miles per hour. So the boat in still water, not including the current, is going 11 miles an hour. Okay, now we can substitute this back into both of the original equations and solve for water. So let's go ahead and do that to these equations that we already simplified. So we have 14 equals boat plus water, so 11 plus water. So the water equals 3 miles an hour. And we have 8 equals boat minus water. And 8 equals 11 minus 3. So water still equals 3 miles per hour. So the current is 3 miles an hour, and the rate of the boat in still water is 11 miles an hour. And that is it for this lesson. Try your practice problems, and let me know if you have any questions. Thanks!